Hello and welcome back. In this video, we will be looking at logarithms. And to really introduce this, what I want to do is go back through a little bit of what we've already seen. And in particular, we have looked at solving an expression for x. So for instance, if I have x plus 14 is equal to 26, so what number plus 14 is equal to 26? Well, if I'm adding 14 to x, I can undo addition by using subtraction. So if I subtract 14, adding and subtracting 14 at the same time doesn't do anything. So what I'm left with is just x. And then on the other side, I've got 26 minus 14. So, and then we could write down the answer to that, which I think would be 12. We also have, say, like multiplication here. Here I have 5.3 times x is equal to 14.7. Well, if I want to undo multiplication, because I'm multiplying 5.3 and x, in order to undo multiplication, I have to divide. So I divide both sides by 5.3, and x would then be 14.7 divided by 5.3. So again, I undo addition using subtraction, I undo multiplication using division. One of the things that we've seen this semester is if I have x raised to a power, I can undo that as well. And this one is maybe the least obvious. These you're probably more familiar with. This last one, in order to undo the third, or sorry, the raised to the third power, we raise both sides to the 1/3 power. So the 3, when we flip it over, becomes an exponent that is 1/3. And this is not something that you could calculate in your head. This would just be something you have to use a calculator for. For instance, Desmos would be able to handle this fairly easily. So then the question becomes, what about if x is the exponent? Here I'm taking x and I'm raising it to a power. What happens if I take a number and raise that to the x power? Well, let's look at a quick example. So let's try to figure out what x should be here. If I take 3 and I raise it to the x power, I get 9. So if we think about this just a little bit, for instance, one thing that I know is 3 squared is equal to 9, right? Because 3 times 3 is equal to 9. Well, that means that x should be 2. So x is equal to 2. That was pretty straightforward. I know that 3 squared is 9. So if I know that this has to be 3 squared, well, that means x has to be 2. And there's not a lot going on. But these are pretty simple numbers. What if we start getting some wacky numbers in here? 7.31 to the x power is equal to 102.4. I don't know that one. This one is hard. So now we need a way to try to figure out what x is. And luckily, we have a way to undo raising something to the x power. There's a nice way to bring x down so that it's not in the exponent anymore. So just like up here, where we can subtract 14 to undo adding 14, we can divide by 5.3 to undo that. We can take the third to the other side and raise this to the 1/3 power. All of these allowed us to figure out what x is. There is a method for undoing this as well. So let's look at this. We can use what are called logarithms. So let's say that I have an equation that looks like this. B to the x power is equal to y. So if I want to know what x is way up here in the exponent. I'm raising b to the x power, and I want to get x by itself. The trick is we're going to use what's called a logarithm. A logarithm is just the inverse of an exponential, meaning that it undoes exponential. So b to the x power, so I've got an exponent. If I'm using a logarithm, that exponent is now by itself. So logarithms take exponents and solve for them. So this is very, very nice. And there is a very particular order in the way that we write things. So b here, so b is called the base. So in this first line, b is going to be the base of an exponent. It's b raised to a power. In the second one, b is the base of the logarithm. This would be read the logarithm of y base b, or the logarithm base b of y. It doesn't matter the order, but we are taking the logarithm of y, and it has a base. Up here, this is b raised to the x power, and b is called the base. And then when we take the logarithm, the exponent that was up here is now by itself. So this is how we solve for x. Let's do a bunch of examples. So I'm just going to use this formula. Here, 2 is my base, and I'm raising 2 to the x power, and that should be equal to 16. If I want to write this as a logarithm, the base, which is 2, stays the base, and I'm going to be solving for x. The 16 is plugged into the logarithm. So b to the x is equal to y. Log base b of y is equal to x. So this is going to be log base 2 of 16 is equal to x. So I've solved for x. And then this would be something that I would be able to plug into a computer or calculator. For the moment, we're not going to worry about it. For the moment, we're only going to be turning these expressions into this, so I can solve for x. Let's do some more. So, I have 7 to the x power is equal to 104. Again, I'm trying to solve for x, so I want x equal to something. 7 is my base. And then the only thing left is to plug the 104 into my logarithm. So log base 7 of 104 is equal to x. The original exponent has now come down, and I've solved for it. Let's do this here. 3 to the a power is equal to 13. So again, 3 is my base, and I'm trying to solve for a. So log base 3 of 13 is equal to a. This is all there is to this lesson. It's pretty straightforward as long as you've got the formula down. So 10 to the z is equal to 14. This means, the log base 10 of 14 is equal to z. Again, z was my exponent. This is what I've solved for. The base of the exponent is the same as the base of the logarithm, and I have to take the logarithm of something. So this is going to be the log of 14. And one final one, here I've got 8 to the c is equal to 3. So again, my base is 8, my exponent is c. So I'm going to take log base 8 of 3, and that's going to be equal to c. One of the reasons that we're doing this will be to help us try to solve some of the financial formulas that we're looking at for interest. So solving, say, some of the compound interest formulas for various things, we will need to use logarithms. So logarithms allow us to solve for the exponent, and the logarithm and the exponent itself have to have the same base. With those key ingredients, the next homework should be fairly straightforward.